Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we will see next part of hyperbolic functions. First, consider differentiation of inverse hyperbolic functions. If y equal to sine hyperbolic inverse x, then x equal to sine hyperbolic y. Therefore, dx by dy equal to derivative of sine hyperbolic y with respect to y is cos hyperbolic y, and which can be written as square root of cos hyperbolic square y, which is equal to square root of 1 plus sine hyperbolic square root of y, which is equal to square root of 1 plus x square, since x equal to sine hyperbolic y. Hence, dy by dx means 1 upon dx by dy. Hence, dy by dx equal to 1 upon square root of 1 plus x square. Thus, d by dx of y, that is sine hyperbolic inverse x, equal to 1 upon square root of 1 plus x square. Consider next example. Differentiate with respect to x log of tan hyperbolic x by 2. Let y equal to, consider solution of this example, y equal to log of tan hyperbolic x by 2. Differentiating y with respect to x, we get dy by dx, which is equal to d by dx of y. Y means in bracket log of tan hyperbolic x by 2, bracket complete, which is equal to, that means dy by dx equal to derivative of log, hence 1 upon tan of x by 2 into d by dx of tan hyperbolic x by 2, bracket complete. Hence, dy by dx equal to 1 upon tan hyperbolic x by 2 into derivative of tan is sec, so that into sec hyperbolic square x by 2 into derivative of x by 2 is 1 by 2. So that dy by dx equal to, after simplifying, we get cos hyperbolic x by 2 upon sine hyperbolic x by 2. That is, we have defined 1 upon 10. 1 upon 10 means cot, and cot means cos hyperbolic x by 2 upon sine hyperbolic x by 2 into sec hyperbolic square x by 2. Sec means 1 upon cos, so that into 1 upon cos hyperbolic square x by 2 into half, as it is. So that after simplifying, we get dy by dx equal to 1 upon 2 hyperbolic x by 2 into cos hyperbolic x by 2. But 2 sin theta cos theta is sin theta. Since here x by 2 terms comes, 2 sin theta cos theta is sin 2 theta, here theta by 2 terms comes, so that we get dy by dx equal to 1 upon sin hyperbolic x. 1 upon sine is cosec, so that we get finally dy by dx equal to cosec hyperbolic x. Now consider relations between hyperbolic and circular functions. For any complex number z, the series 1 plus z upon 1 factorial plus z square upon 2 factorial plus z cube upon 3 factorial plus dash 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 is absolutely convergent, and the limit of the series is denoted by e raised to z. Thus, for any z which is a real or complex, we have e raised to z equal to 1 plus z upon 1 factorial plus z square upon 2 factorial plus z cube upon 3 factorial plus dash dash dash. Similarly, for any complex number z, we define sin z. We know that sin z equal to e raised to iz minus e raised to minus iz upon 2 factorial, and cos z equal to e raised to iz plus e raised to minus iz upon 2. Similarly, we can define tan z. Tan z equal to sin z upon cos z, and after substituting the results of sin z and cos z, we will get formula for tan z. Similarly, we can define cos z which is equal to cos z upon sin z. Sec z equal to 1 upon cos z and cosec z equal to 1 upon sin z. By substituting results of sin and cos, we will get these results. Almost all the trigonometric identities which are true for real z, which is purely real number, also hold for complex values of z. Also, for complex value of z, we get sin z equal to z minus z cube upon 3 factorial plus z raised to 5 upon 5 factorial minus dash dash dash, and cos z equal to 1 minus z square upon 2 factorial plus z raised to 4 upon 4 factorial minus dash dash dash. We get these results for complex value of z also. Since for real value of x, we know the result sin x as x minus x cube upon 3 factorial plus x raised to 5 upon 5 factorial minus dash dash. Similarly, we get these results for complex values of z also. That means for real and complex, we get the same results. Now, consider sin z equal to e raised to iz minus e raised to minus iz upon 2i. Replacing this z by iz, we get sin of iz equal to e raised to I, z is replaced by iz, minus e raised to minus iz, that is replaced z by iz. After simplifying, I square equal to minus 1. So that after simplifying, we get sin of iz equal to e raised to minus z minus e raised to z upon 2i. I square is minus 1 and minus I square is plus 1. So that we get this result. Sin of iz equal to, we take minus 1 common. So that sin of iz equal to minus 1 into bracket e raised to z minus e raised to minus z upon 2i, which is equal to minus 1 can be, which is equal to I, sin of iz equal to I into e raised to z minus e raised to minus z upon 2. This term I results as in previous step we have in bracket minus 1. Minus 1 means I square. I square is I square root of minus 1. Take minus 1 as I square and we have divided by 2i. So that one terms I cancels, so that only one terms I remains. So that sin of iz equal to I into e raised to z minus e raised to minus z upon 2, which is equal to I sine hyperbolic z. Since sine hyperbolic z equal to e raised to z minus e raised to minus z upon 2. Thus, sine of iz equal to I sine hyperbolic z, or sine hyperbolic z equal to minus I sine iz. Since sine hyperbolic z equal to sine of iz upon I, and upon I can be replaced as minus I square upon I. That is one term only, minus 1 remains. So that sine of sine hyperbolic z equal to minus I sine iz. Similarly, we can show that cos of iz equal to cos hyperbolic z, and tan hyperbolic iz equal to I tan z. That means replacing z by iz, we can simplify any result. Also, sine of z equal to e raised to iz minus e raised to minus iz upon 2i, which is equal to 1 upon I sine hyperbolic iz. Since sine hyperbolic iz is e raised to iz minus e raised to minus iz upon 2. That is sine of z equal to minus I sine hyperbolic iz. Since 1 upon I equal to minus I, replace here 1 by minus I square and divided by I, so that we get minus I term, and sine hyperbolic iz as it is, or sine hyperbolic iz equal to I sine z. Similarly, we get cos hyperbolic iz equal to cos z, and tan hyperbolic iz equal to I tan z by simplifying the terms as above. Thank you.